Hi everyone, it is Miss Sheri back with this. That's not really the moon. It's just a toy. But I do want to talk more about the moon, which is an object that you would see in the night sky, right? The moon is basically a big rock, a big dusty rock, and it orbits or goes around the Earth. Now, we don't need a telescope to see the moon, usually, right? It's usually the brightest and biggest thing in the night sky. It's the thing we can see the easiest, except sometimes we don't see it, right? Sometimes you can only see a little bit of it. It's because the moon actually goes through phases. These phases are, well, they look like different shapes of our moon, but they're not different shapes. The moon doesn't change. It's always round, just like this. Right? It's always round, but what does change is where the sun shines on it as it orbits our Earth. Right? And as the sun changes where it's shining, it looks like the shape of the moon changes too. So there are 8 moon phases. There's a new waxing crescent, first quarter, waxing gibbous, full, waning gibbous, third quarter, and waning crescent. And then we start back with new moon again. And that is one whole cycle. Now, these moon phases, they actually help us to tell something special. It's time. People used to use the moon, and still do today in some places, to tell time. The very first calendars were created using these moon cycles, using the phases of the moon. They were called lunar calendars, and it was how people figured out how time was passing, how they figured out when to do things, when to plant crops, when to move from one location to another if they were nomadic or people that lived in different areas depending on the time of the year. Our calendars now, modern calendars, are based on these ancient lunar calendars, which is pretty cool. Now, our moon is special in a couple of other ways as well. The moon is the only other place besides Earth that humans have been. Astronauts went to the moon and they landed on it. 2 of them. There's Neil Armstrong and Buzz Aldrin, and they stepped on the moon for the first time. They stepped on a place that wasn't Earth for the very first time. It's incredible to think about going to a place and standing there and looking at Earth instead of standing on Earth looking to the sky at the moon, right? Well, it was pretty awesome. And there's actually some stuff still left there from when those astronauts visited. Specifically, their footprints. Astronauts' footprints are still on the moon? Yeah. And you know what? They probably always will be, or at least until something comes along to change them. There's a big difference between the moon and the Earth. When things happen on Earth, if I go outside and step and I make a footprint in the dirt, it'll probably rain later, and then my footprint gets washed away, right? Or what if you go to the beach and you're walking along the beach and then the wind starts to blow and it blows all the sand across your face, and then you look down and all of your footprints are gone. The wind has blown the sand around and it changes the shape. It changes your footprint. It's not there anymore, right? That doesn't happen on the moon. And that's because the moon has very little, almost none, of something called an atmosphere. That's the air around a planet or a moon. The air around it that gets stuck, it's held towards the body, so like a moon or the Earth, by gravity. And it holds this air in around here, lots of gases. And sometimes inside of that atmosphere, there's weather that happens. So kind of like on Earth here, when we have wind and rain and snow or even ice, all of these things change the way that our Earth looks. It can change the way a mountain looks over thousands of years. It will change the shape of the creases in the mountain, the cracks in the mountain, how tall it is. It'll get smaller. It will erode as our weather, especially water, affects it. Moon doesn't have that, right? So those footprints will stay there forever unless something changes. But there are things that can affect it or change the way the surface looks. Now, sometimes if you look at the moon at night, you can see things like craters. Yeah, craters are where the meteoroids will impact the moon. And as they hit, you've got usually a circular shape there, and it forces all that ejecta out. You may see some lines on the outside of the craters as well. They're basically just big holes in the moon. Now, sometimes there's some shadows in these craters, which can make a pretty dark looking color on the surface of the moon as well. Sometimes dust can also make it a darker color. So even though the moon looks white because of the sunlight reflecting on it, we often see darker gray colors on there as well. And these changes in color, darker gray or white, sometimes they even form patterns. These patterns can be referred to in kind of a silly way. You ever heard of the man on the moon? Or what about an astronaut walking a poodle? So if we had a meteoroid that came and smashed into the space where those astronauts' footprints were, the footprints would be gone. And in their place would be a big crater with these little lines that come out of the side of it. Let me show you again. See those little lines coming out? There's a crater and there's these lines, right? That is called ejecta. Ejecta is the stuff that gets forced out of an impact crater when something hits something. So when we're talking about the moon, if a meteoroid comes and hits, all this stuff flies out of it. And because there's no atmosphere on the moon, it'll stay like that. It won't change until something else comes along and hits it again, right? Now, I have an experiment that you can do with me if you'd like. This experiment is going to help us to visualize that ejecta that I mentioned earlier, or what happens when a meteoroid hits the surface of the moon. Kind of throws some stuff out of the sides, right? So if you'd like to do this experiment, you need a few things. You'll need a plastic bin, and inside of this bin or container, you want to put about 2 to 3 inches of flour, and you'll get this from your pantry. It's the stuff you bake with. Another thing you'll grab in your pantry there is some cocoa powder. This cocoa powder is going to go on top of our flour. I use a sifter here to kind of make an even layer over the top of my moon's surface, but you don't have to use a sifter. You can just use your hands. You don't have to use cocoa powder either. You could try dirt or instant coffee or any kind of a powder that's darker than flour will work for this. So you'll get your moon surface covered with that cocoa powder or whatever else you choose. And then it's time to have a meteoroid impact our moon's surface, right? Now I'm going to use a rock. I'm going to drop it. And as I drop it, you'll see when it impacts the lunar surface or our cocoa powder and flour in our bin, it sends a bunch of things shooting out the side. That is ejecta. That's exactly what you see on the moon. It forces material out of the sides of the impact area. So you've got a hole, a crater, and then you've got ejecta all around it there. And you can see there are light colors and dark colors on my moon's surface now. Now, you don't have to do the things exactly like I did. Of course, you use the materials that you have at home and make this experiment your own. You could also try dropping an Easter egg or a plastic squeezy bath toy like I did. It doesn't have to be a rock or even something round. Make this experiment your own. Now, I'd love to see what you come up with. You can use the hashtag MOSHJax on social media and show us what it is that you decide to do with your moon surface. Hope you have a great time. Thanks for watching.
MOSH Connect relies on support from our community. If you like what you just saw, please consider donating at www.themosh.org and give us a like on social media at MoshJax so you can stay connected.